of a historic crisis, which means that fewer resources are available in order to be able to protect our climate. The top issue prior to Corona. And there are those that think we do not have the resources to go on protecting climate. And there's another group of people that are saying that from previous experience, we know that crises have a tendency to reinforce trends. And this is the spectrum here that we wanted to elaborate on. And we have 4 good speakers that have all arrived here now, dealing with these issues more from an bird's eye perspective. The first 2, I think, and then we're going to go over to a level that is more practical and that deals with one of the solutions, power to X, from 2 dimensions. And I'd like to thank our sponsors. Our one sponsor, that's Wintershall Dea. That's a company that was it spun off? I don't know, or it's a subsidiary of BASF from Ludwigshafen that deals with oil and gas and has obviously an interest in energy. And they have been helping us setting up this conference. And I would like to present to you our first speaker, who has that big question right before him. How sustainable is sustainability? The pros and cons in the light of the crisis. It's Michael Torndal-Simmelsgaard, and he is Managing Director Energy of Rambøll, an engineering company from Copenhagen. And Michael, and to all participants, we want to make sure that we stick to the time frame, and that is why I have a countdown running here for you that is timed at 20 minutes. And so
I better get started.
You'd better get started, otherwise I will eat into your 20 minutes. Michael, the floor is yours.
Thanks. And what a fantastic view for those of you who is not all knowing what we are doing. Then you of course have the waste to energy plant, which is a fantastic engineering masterpiece, and basically part of what we are going to discuss today. So if we look at it, then just a short introduction. Then Rambøll in brief, it's an engineering company. It's a design consultancy. So we just by New Year bought Henning Larsen. So trying to integrate that throughout the crisis. But basically, we are an engineering company, and then at the same time, we also have a management consultant department. We are all over the world. We have approximately 300 offices, widespread in US, widespread in Denmark. Unfortunately, Germany, we are still struggling to get a position. Our CEO, of course, you know him very well. So yeah, Jens Peter Saul is that's one of the things that I'm sure he wants to achieve very fastly. We are approximately 16,000 people. Of those, 2,000 is in energy. I'd just like to start with a simple picture which cannot illustrate any more simple what we are up against. And you ask the question, is sustainability sustainable? We don't have a choice. That's as simple as it is. And yes, I'm not going to make a Trump, meaning that I'm going to tell you that the crisis we are in is not severe. But I'm also going to tell that if we don't do anything, then the crisis behind it is even worse. So from that point of view, I think it is critical that we keep that in mind no matter what we do. So let's get over the crisis and let's get further on to actually make a change for the world. We are currently estimating that we are gonna reduce by CO2 emission by 2.6 this year, which in the variety of all estimations that we have is within normal viability of a year. So do we still need it? We are not flying. Factories are closing down. Energy consumption is down by 20%. Part of that, I'm painfully also in oil and gas. Oil and gas is massively down, as I assume you're fully aware. But at the end of the day, compared to what we need to do to basically achieve what has to be achieved to reach the Paris Agreement, meaning the 1.5 degree increase, what we have reduced this year is not fully comparable. We were discussing it whether it was about the same, but it's around half the reduction we have had this year. We have to have an average going forward. So that gives you kind of the perspective of what is in front of us. So if we look at it, then 2018, I was lucky enough to be part at Frederiksberg municipality to be part of the announcement of the EIA report around offshore, but also their global reports. And if you looked at it, then no matter how much we talk about carbon emission, it continues to increase. So it's almost the same as you experience with fixed cost in any other average company. So it's the area which no matter what we do, no matter how much we talk about it, it still increases. We're looking currently at a drop. By the way, the biggest drop since World War. So it's the biggest drop in history. But if you compare, then it's the same as a consolidated drop all the way back from World War II. That's just to give you a slight idea of the magnitude. And we have to do that in average, half of that every year for the next 10, 20 years. Just not to put any pressure on anyone what we actually need to deliver. So can we wait? Is it sustainable? My true belief is we don't have a choice. What is actually going on? The energy sector has dropped basically all investments all over the place. The only good thing is, of course, to see that the biggest drops has been in the non-sustainable sources. We are living in the Nordics. And for us, it is intuitively logic. You live in Germany, so let's not call it Nordic, sorry for that. But we live in an area where we talk about the energy transition being handled by offshore wind, onshore wind, solar. We talk about hydrogen. We still need to remember that in the global scheme of CO2 emission, 70% of all energy consumption around the world is done by oil and gas. 70. Offshore last year reached an amazing 0.5% of the energy demand. That's offshore. But of course it can be done, but it just tells you the magnitude of the transition that has to happen for the environment. So is it gonna go to other directions? Is it a safe investment to go into to renewable energy? Absolutely. And I'm 99% sure it has to continue because our choices are not there. What is the bad part of the story? The bad part of the story is, of course, that no matter what we're looking at, then yes, the percentages of renewable investments are increasing. But that's only when you remember that there is both a counter and a denominator. So when you look at the total, then we actually see all the renewable investments also going down, both in energy efficiency, and we are also looking at all the other renewable sources going down in 2020. That's a bit scary if we go back to the ambition. So for me, the clear message is that we truly don't have a choice. There's a lot of academic discussions on which of these scenarios here that is the right one to do. None of the scenarios ends below the original zero line, which means that the power plant you have over there will need to capture carbon. Also the one you have over there, Rune, that also has to capture carbon. Because we need to do enough to actually keep the targets. I'm a true believer that actually reaching the 1.5 degrees is important. And when we speak here, I'm sure that the majority of you have the same view. The problem is the rest of the world might look at it differently. What we are currently looking at is, of course, what can we do around the globe to increase the investment in renewable? It is, of course, important that the merit order of investments and decisions to be done is different depending on where you are. We all hear offshore wind, we hear onshore wind, we hear Germany, south, you hear solar panels. You also see that in Denmark, but not to the same degree. But if you then look at it, then there are other emissions, other things that needs to be done in the meantime. I'd just like to put things in perspective, that if you look at Baltic Pipe, which Energinet, where are you, is building, is reducing the CO2 emission in Poland 3.5 times the targets that we are talking in the 07 plan for Denmark. That's around 19 million ton. Baltic Pipe is, I believe, is around 70, not taking your presentation. So it's 3.5 times the reduction in the global scale. We need to be aware that not everyone lives in Sweden where there's hydro. Denmark, where we have a grid and we have offshore wind. Germany, where you have solar, you have hydro plants. But be aware that all the investments that can reduce the global carbon emission is important for our world. And then, of course, the second step, energy is only a small portion. I'm actually sure that the energy generation is actually going to fulfill the targets in Denmark. In Denmark, you know, we set out the 70%. The 70%, I'm sure that those will be reached. It's not cheap, but it can be done. But whenever we are there, remember that the energy part of it is only a small portion. Then we need to look at industry, removing carbon from that side, and of course, heat transforming and also the transport transforming. Those all have to happen to be able to do that. So the main message is, of course, that it can be done. We truly believe that we have to come out stronger. We talk about the energy island. Energinet does the same thing. But if you look at it, it's all about connecting the European grid in a smarter way. Whatever is going to be placed on that island, here it looks rather cozy. And you know, you have a beach and a golf course. I'm not sure that that's the place to be in the North Sea. If any of you have been working offshore, then then that's the turbines will not be spinning at any decent Gulf weather. So that's not going to happen. But what needs to happen is, of course, that we need to enable it. Denmark alone, we have to build 16 gigawatts of offshore wind. That's what it takes to get balance to the 7-0 plan. 16 gigawatts. What's there now? 3.5, 4. So it's just making it 4 times as big. That, of course, then talks about the integration. Ørsted was out with a fantastic announcement of the hydrogen factory out here. And that's, of course, fantastic, because those are some of the investments that we need to see. And it's really good to see both in the German recovery plan and in the Danish recovery plan that those things are in focus. Go back and make sure to put all the pressure you can on making that happen, because that's going to be one of the new big adventures. Carbon capture. Back to my first slide. It is incredibly expensive to store carbon. That's a rumor. We do talk about what is it in total, 1,200 per ton. But that was also very expensive when we talked about offshore wind some years ago. So if we can do the same adventure to the emission direct out of the chimney over there, then what's wrong with actually sorting the waste in the chimney, get some carbon out, either store it or create new plastic or whatever, methanol or whatever we want to use it for in a Power-to-X process, which you'll hear more about later. But making sure that we keep our head start towards all the other ones in this business, that's critical. There's a lot of discussions about actually burning the waste these days in the press. I drive from Jylland, so I have 2 hours every morning listening to P8, and that's a lot on how bad it is. And yes, of course, if you emit CO2 like that, but try to imagine that you can get that out, and try to imagine that that's recycling. Offshore wind is in the plan in Germany for the recovery plan. The only challenge, now I've been in offshore wind at least some years by now. One of the challenges is, please make sure that you remember the grid investment that goes along with it. Because keeping it north of Hamburg is not really going to make it fly. And having to convert it to hydrogen, transport south, and then convert back to power, that's cumbersome, even for an engineering company. Of course, it's good consultancy, so we, of course, will do what it takes, but that's still not the smartest way to do it. So basically, the whole transition and whatever we do in the markets right now are important going forward. So the message from me is sustainability sustainable? We don't have a choice. And I hope some of the other ones will confirm that it's actually doable, because at the end of the day, it is known technologies. It is incredibly known technologies how to do a hydrogen plant. Everyone has done that. We've seen almost every country around the world have done some kind of attempt to it. It works, it's easy. The only problem is that 1.5 gigawatt is a lot. And stacking it is not really that easy. If we look at carbon capture, it's done. But we just need to scale it. It's no different than a lot of the other industrial adventures we have been through. It's just a question of being committed to do it, but also being committed to let the scale grow the cost reduction that is needed. So with that said, and actually I believe it ahead of time, even that the counter is black. Then if there's any questions or...
Manage to stay within your limits, and that is why you are allowed to take some questions.
Exactly.
Yeah. Do you see photovoltaics in this?
I truly believe that all of it is needed, and every market take difference. I'm also very positive towards onshore wind, even being in front of maybe people that could be against it. Then I truly believe that there are areas where you need the decentral portion of photovoltaics. There are times when you need onshore wind for smaller grid areas, and no matter what you're looking at, then any projection going forward is that it will be a mix. For the total volume, there's no doubt in my mind that offshore will be the biggest one. But still, it will be a significant part that comes out of both photovoltaics and wind.
Also considering that it's substantially more expensive to go offshore wind.
That's something which we can discuss later over a drink, because offshore wind is truly not more expensive, because you have a lot of benefits in the offshore wind build out that that is reduced compared to your onshore challenges, and also basically, if you look at it, I have a background from Vattenfall. We were building at merchant risk in the Dutch market, so and Ørsted is preparing to build at merchant risk in the German markets, which means either they are massively stupid, including myself, or they can actually do it rather cheap. I had an internal competition with my head of onshore wind, and I ended lowest.
I was talking about photovoltaics, not wind.
Okay, there's no doubt that for parts of the world, then photovoltaics is a good idea, and absolutely, if you can do the hydrogen factory in Morocco with photovoltaics at 7 cents per megawatt, then I'm fine. Then I'll follow you down there, and I'll help you build the hydrogen factory next to it.
You can do it cheaper than that.
No, but that's absolutely. I fully agree that that's definitely part of the future mix. No doubt about that.
Thank you, Michael, for the overview. You mentioned another great Danish company, Ørsted, in your presentation, and that will come on now. We have here with us Rune Bunker Jørgensen, who is head of commodity and strategy at Ørsted. And Rune, you're going to talk about green energy during and after the COVID-19 crisis, and we talked about you taking a look at different energy markets. The floor is yours. Actually, this is the microphone for this event, and this is the microphone for the online participants. So if you can stay here during your presentation, sure. That will be good and best for everyone. Thank you.
Thank you. Good. Thank you very much for having me. It's an honor to be here. It's a topic that's obviously extremely close to our hearts in Ørsted, sustainability and the journey that we are on. Before I get started, I actually just, in case you doze off let me give you the 3 points I'm going to make up front, so you know. The first one was already stolen a little bit, but the COVID-19 crisis has just been a tremendous shock to the energy markets, and I'll try to take you a bit of a tour around some of where that has hit us. I believe that renewables are coming out quite strong in that. I'll take you through that. And then the last point, just as Michael mentioned, we can't as an industry do it alone. And this is a massive build out. This is a massive challenge, and we're going to need a bit of assistance throughout this journey. So I head up our B2B division in Ørsted, and as I usually say, I work in the coolest company. I work in the new Google, the world's most sustainable company. It's a phenomenal place. I think most of you will have heard the story, but I like telling it, so let me just go over it again. A decade ago, 95% of our energy generated came from fossil sources. By 2023, none of it will. That's just an absolutely tremendous journey. By 2030, we'll go net zero. By 2040, including our own supply chain, both of these things will take us, at least we'll do our part in taking us way ahead of what is required for the Paris Agreement. Unfortunately, we're not alone in the energy sector, so a lot of people have to join, and we are on a global scale tiny. We like to think of ourselves as massive in our own little carved out niche industry, but on a global scale, we are tiny. Ørsted is by now a global company. Wind started out at very humble beginnings in Vindeby. It's not even on the map anymore because we decommissioned it. I took here a picture of the stuff here that's relevant. Our parks in Germany, Borkum Riffgrund and Gode Wind. We have our parks in Denmark, but we of course have a large presence in the UK, building up in Taiwan and building up in the East Coast. And if you run the projections forward, by the end of this decade, the vast majority of our revenue will come from outside of Europe, which is a very, very interesting journey. We currently have, if you add up the numbers, 14.6 gigawatt in operation, another 17.3 under development. And Germany is very important to us. And Germany is a market that we're very keen on winning. And Germany was the first market in which we went subsidy free, and we have high hopes for that market as well. But enough about Ørsted. Let's talk a little bit about what happened in the COVID-19 crisis, and it's been bad, as in really bad. If you overall energy demand is down by, according to IEA, down by or expected to be down this year by 3.8%. That is the biggest drop ever. Again, ever. We've never seen this before. I could take this graph. This graph actually goes back all the way, 100 years back. It starts in 1900, so it goes back 120 years. We've never seen a drop like this. Just to put it in perspective, when we talked about Michael's second wave, about the recession potentially coming, and that of course is bad. The negative change in energy demand is 7 times larger than what we saw in the 2008 financial crisis. It's very unevenly distributed though. Oil demand was down 9%, coal down 8%, gas down 5%, nuclear, our good old trusted baseload capacity, down 3%, renewable up 1%. So that has been interesting. If I just go a little bit closer to home and look at some of the data that I can look at with my customers primarily in the UK and in Denmark, we've seen a like-for-like drop quarter to quarter compared to 19 of close to 15% drop in B2B in the first couple of months. It took a massive dive and then it leveled off, and it's slowly coming back up, but not where we were. In Ørsted, we've seen an increase in the residential demand, and obviously you can all see where that is coming from when everyone's not using their computers at work but at home. But overall, it's led to quite a decline. The problem with this decline in demand is that it didn't happen in a vacuum. The problem was in the European energy markets, we have over the past 2 years been, especially around gas, which is a key determinant of the price, has been extremely oversupplied. So if you take an oversupplied market and you suddenly yank away a lot of demand, this happens. So prices tanked. And I haven't included oil here, which was the big story, of course. Oil going in some sort of niche, going negative even. We saw a massive decline both in power and in gas prices, coupled with a decline in demand. That means that your revenue takes a double whammy negative. So it's been interesting. The what happened in the European markets is, as many of you will know, of course, we are in many ways the sink of LNG, where that goes. We can't really turn down supply. I mean, Norway or Russia could, but they don't. When you then get a really cold winter, as we had 2 years ago, the beast from the east, you get price signals that tells LNG shippers to ship to Europe instead of shipping to Asia. So that led, so that demand started coming in on long-term contracts. So we built up demand about a year and a half, or we built up our stockpile across Europe a year and a half ago. And then came winter. And if you remember winter, not this one, but the one before, didn't really happen. So we didn't really draw on our storages. We would then normally spend the summer refilling, so already there, very, very weak demand. And then this winter came, and again, didn't really. So we had, again, we're running out of places to store gas. We have converted all of the plants that could convert from coal to run on gas. Instead, we've changed all of the mix, and then comes this drop, and that is what leads to this tank in prices and this volatility. So it's, for large energy consuming companies, if they've been on spot contracts and have done it well, it's a good thing. But in any case, such large uncertainties and such large changes are just not good. It's very hard for predictability. So the first takeaway, as I promised, is that this has been a very, very deep shock to the energy industry. And luckily, and I'll come back to that, luckily that's also caused a couple of companies to rethink what their futures should be like. But let me just for a second take you into the engine room of everyone here has had their own challenges around COVID-19. In Ørsted, we've had the same challenge as everyone else with office workers suddenly having to work remote. And we are back here in a room today, and that leads us to forget a little bit that there are many parts of the world where that is not the case. I have an entire UK organization that has been on lockdown since March, and I don't expect them to see the office until September. This is serious for people. In Denmark, we had the nice version of it. We learned how to use virtual. Everyone works with Teams. It's nice. I actually had, for all of my employees, we could see sick days. I haven't had a sick day. No one's had. So sick days down, productivity up, great. But it's challenging. George, one of our managers in the UK, he has now for 4 months sat at home, and he has another 3 or 4 to go before he can go back to the office. And he sits around a dining table with his wife, who's also trying to video conference in with her work. And around the same dining table sits their 2 teenage daughters who are getting remote education in one room. And that has to happen for 7 months. I mean, this is crazy. We of course, a deep safety culture in Ørsted, and we are concerned about people's mental health in this situation. And that's just for office workers, right? Then we have the challenges around, as I had before, we're a global organization. We have global supply chains. We have an integrated global supply chain. But if you suddenly can't, and we have very highly specialized technicians, spare parts, all of those things, if you can't move them around because the borders are closed, that's a real challenge again. Now, we didn't see, and I think we're over it now, but we didn't see any major outages, but it could have happened. There were a couple of our plants where it was close, and if a certain event had happened, then it would have been bad. Then we have people going on vessels. If you remember the Diamond Princess in a Corona pandemic, you don't really want to be locked up on a vessel for weeks at a time. So we had to divide, again, there's no real help. No one's been in this situation before, so we had to devise strategies for how to do that. And what we chose to do was we had everyone come there, go straight into the individual cabins, isolate themselves. They got a test kit slid under the door, self-tested. A doctor came and monitored. Everyone sat isolated until everyone was cleared, and then the boat was sort of self-isolated and sent out. And the vessel would then stay out for longer, and we wouldn't normally shift. So it's been a lot of employees have had to take a lot of personal sacrifices to actually keep working in this. And that's one of the things we're drawing on, a lot of personal sacrifices for our employees, and we're very proud of how they've managed through. So it's been financially challenged for the industry in general, and it's been putting management to a test. But the good thing is that this also happened. Now, this doesn't really say much, but you probably can't read, but it was in the news, I think it was last week, a week before. UK hadn't burned coal to provide energy for more than 2 months. It's of course a combination of gas and renewables, but that's phenomenal, right? That's the first time that happens. We've also seen severe stretches of negative prices. We don't like that, but yes, we have a massive challenge ahead of us, but there are silver linings everywhere where we see things starting to happen. And I put up the logos of what will hopefully in the future be some of my main competitors. Even in this crisis, or I would actually argue potentially because of this crisis and seeing their business models potentially erode in front of them, all of these companies announced net zero targets by 2050. BP did it in February, Shell did it in April, and Total as late as May, which is, during the crisis. And in all of this, they still decided, and again, I would argue probably because of it, decided that they fundamentally have to change. And this is my second point. It's been bad, but it was probably the shock the industry needed to really be shaken out of complacency and say, okay, we really have to do something. And if these guys join us on this journey, it'll be hard for us, but it's going to be the right thing for the world, because we're going to see the capital cost go down with all of the knowledge that these guys bring in. But we can't do it alone. And this is my third point. We are a large company, a small company, depending on how you look at it. We talked about merchant risk. We generally don't like merchant risk. Merchant risk leads to higher volatility. Higher volatility leads to our investors requiring a higher return. A higher return leads to higher capital cost. Higher capital cost leads to fewer renewables being built, and fewer renewables being built is obviously bad. So ergo, volatility for us is a bad thing. And this is one of my main messages, is that as a society, we should probably come to terms with the industry can't do it alone. This is going to be a joint effort. We had as Ørsted, some phenomenal deals in the past where we were protected against the downside and had an unlimited upside. That world has gone. We're willing to forgo the upside as long as we are protected against the massive swings in our merchant exposure. We also need to continue the currently really, really good dialogue that is between regulators, between industry players, between governments, about understanding what it is the industry needs at any given time. Sometimes it's macro, like grid congestion in Germany. Solving that problem would massively increase the opportunities for wind in the North Sea. But it can also be really small things. Again, coming to the UK, where we have essentially two types of vessels. We do operation, that's deemed critical. So we're allowed to sail with that, we're allowed to send people up, but we also erect new wind parks. It's basically the same type of work, but that we're not allowed to do because it's not deemed critical infrastructure. As soon as we commission it, it becomes critical, but building it is not. So it's in the big things and in the small things that we have to work together as regulators, governments, public, and industry. But I remain an optimist. I look at this in just look around us at what we did from a coronavirus that led to a cross the political spectrum, cross interest resolve in getting stuff done, taking tough decisions. If we apply even halfway of that resolve into the green journey, it's going to be okay. And that's my hope, and that's the journey that Ørsted is on. We can't do it alone. The more the joint industry, honestly, the better. And let's not go back. Let's not go back to working in the office. Let's not go back to doing stupid commutes. Let's use all of the stuff that we've learned. It's not enough. It's nowhere near enough. but it's a tiny start. And then let's use that resolve to create a world that runs entirely in green energy.
You managed well, both in terms of content and also in terms of time. So we have another 4 minutes now, in which we can take questions for you. Also, to the online participants, you can type in questions via the chat stream. But is there a question from here? That's Morten.
Yeah, 3 energy companies you show all major European energy companies. As we know, the problem with CO2 is not a major European problem, actually. I believe the EU is accountable for about 15%, so that's quite low. So we need the rest of the world to join us in that. What do you think about that, the perspectives? I'm mainly thinking about China and the US here, of course.
Yeah.
Just repeat the question.
Yeah, so the question was for those online, Europe is only part of the solution, and when I mentioned 3 European based competitors. What about US? What about China? How do I see that? To be completely honest, I try not to think about, as a human being, I try not to think about it too much. I recently went on a long trip in the US, and the challenges that we face there with it'll require, not only do we need the energy companies on there, and that's challenging because it's an entirely different market. It's a much more decentralized market structure. But we need a fundamental societal change. It is a society where in the US, where you've literally physically constructed your cities to drive large trucks, pickup trucks in and out huge distances. This is not, one, it's not easy to electrify, and even so, it's such a dispersed and large country that the challenge of getting there is, I'm not going to say insurmountable, but somewhere in that vicinity. In the end, I don't know, but I'm an optimist. I am a believer in human ingenuity if we're just put under enough squeeze and pressure. And again, we need the US energy companies in this as well. But the journey of first understanding and accepting and feeling, the journey that we've been on in Europe for decades now, it's going to take a long time. And then the society is just structured so that it is on top of that extremely hard. So not the most optimistic answer, but yeah, I'm more positive on China. For better or for worse, they have an ability to decide and do things. And in a way, if they choose to decide, and we can argue from here on to the end of the world whether that's the right way of doing things. I'm not going to say that, but they have an ability to get decisions through. I'm more concerned about the US.
Great. I think, well, thank you, Rune.
Great
presentation. Also for coming in on other subjects like the way you're working at Ørsted with all the challenges and problems you were facing during these last 3 months, and you keep on facing there in the UK and other places. This was the big picture, I think, from both of you, Rambøll and Ørsted. And we're going down now a bit, and I would like to introduce to you Torben Frank, who is a director and partner at Incentive, which is an energy consulting company. And Torben, you have worked on 1 or 2 studies. I think it's actually 2 studies. Your presentation is titled "The Potential for Power to X in Denmark and the EU," and that's again 20 minutes for you, Torben.
I'm not sure I can do 20 minutes. We'll see how it goes. What I'm trying to, the takeaway here is, like, in Denmark we have certain words which we all agree is a good thing, like the Danish model or the green transition. Nobody really knows what it is, but it's a good thing. Power to X is a little bit the same. We hear the word, we think it sounds good. I'll try to explain what it really is. So first a little about Incentive. Rune said that Ørsted for some was a small company, for others a large company. Well, we are definitely a small company. 30 people, we try to specialize in doing economics in a number of fields. Energy is one of them. First of all, the challenge. Why do we talk about changing the energy system? Michael had a chart that was showing more or less the same as this is doing. This is taken from IEA. I think this is the clearest picture of the challenge for the energy system. We're going from in a direction where in the developed world, we're going stable on energy, on CO2 emissions. We have to go steep decline. For the developing world, it's an even steeper reverse of direction. So it's a huge change. And we may think in Denmark, where we think that we invented the wind turbine, and we're doing a lot of good things. So we have done the green transition. In reality, we have not. In Denmark, only a small percentage of the energy consumption is renewable. In Denmark, we still run on fossil fuels. All the transport you'll see on the table here, it's transportation that's using most of the fossil fuels. So we have not moved to green energy yet. And even if you look at Europe, the electricity sector is still predominantly fossil. Of course, we have done a lot on growing, trying to build offshore wind. We've done onshore wind. We're doing photovoltaics. Actually, I think I'm on the photovoltaic side of the electricity price discussion. I think that one of the big opportunities we have is that photovoltaics seem to be driving prices, electricity prices very, 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 very low. But it's a matter of trying to get this done. I also, if I forget it later, one of the things is that all this transition to a renewable require more electricity. So in reality, there's no limit to how much we can build out offshore wind or onshore wind or photovoltaics. We're going to need all the electricity. It's more maybe it's more a matter of permitting than on finding the investments. Okay, so what is Power to X? This is an economist's version of trying to do something that's engineering. So you start with something that's renewable electricity production, then you put it into an electrolyzer, you make hydrogen, and then from the hydrogen, you mix it with something, or either you use the hydrogen or you mix it with something and do some other fuels that are still renewable. And what are these other fuels? This could be methanol, it could be ammonia, it could be maybe even biomethane. So a number of different fuels that are renewable, but made from hydrogen as the primary feedstock. This is maybe difficult to read, but in reality, the good thing about IEA did a very, very good study in 2019, where they tried to evaluate how many of the current energy uses can we substitute with hydrogen or hydrogen-based fuels, and the answer was almost all of it. It's just a matter of the cost of first producing hydrogen and then converting it to the other fuels. So, and the good thing about this is, if you think about it, okay, we want to replace all the fossil fuels. With what? What are the alternatives? Yeah, biomethane, or in Denmark we like biogas. We may even think we invented biogas. We haven't, okay? And the thing about biogas is it requires feedstock. And unless we want to start, instead of growing food, we want to start to grow energy crops for biogas, there's not enough potential in biogas to drive the green transition. If you ask the IEA, biogas has in reality no role in the green transition. It'll be a small local thing. I think Stine is promoting some things that I think are very, very smart, where you in Denmark, because we have the feedstock, it's agricultural waste. So in reality, it's something that will turn into CO2 anyway. But if you combine this with hydrogen, we can actually make a business out of it. I think that's a good idea. But I also think that's a local solution that in reality does not have potential to be big scale in Europe. Now, the thing about this, I like Power to X, and I think it's a great idea. I also think that Ørsted's plan for building a 1.3 gigawatt electrolyzer is a good idea. The only thing is that's not what they're doing, right? They're building a 10 megawatt electrolyzer. Then there are plans in the next 10 years to build 1.3 gigawatt. But I think, and maybe I also forget this to say this later, I think somebody needs to decide today or tomorrow or the day after tomorrow to build a 1 gigawatt electrolyzer, so we can see what can we drive the cost down to. Now, what does it take to build Power-to-X? The challenge with Power-to-X is that it does not exist. There is nothing, right? There is no consumption of hydrogen. Nobody uses hydrogen, or chemical industry uses hydrogen. Maybe even steel production uses hydrogen. In reality, nobody uses hydrogen because it's more expensive as an energy fuel than gas. Is anybody producing hydrogen electrolyzers? Nobody is producing hydrogen electrolyzers. So it doesn't exist. Does anybody have any pipelines where you can transport hydrogen? Nobody, right? So this in reality is a start from scratch. Now, the good thing about this, we've done it before. I'm so old, I remember then when we built the natural gas system in Denmark. We decided, okay, we want to replace coal and oil with natural gas. So we found somebody who could produce natural gas. We found some consumers that could use natural gas, and we built the natural gas grid. So we've done this before. So I think we have to decide, this is a challenge where we have to build all the things at the same time. Not easy to do thing. I think that doing 3 things at the same time is not simple, right? This also just to show you the cost of hydrogen. Why does nobody use it? It's 4 times more expensive than the alternative. So we have to drive down cost of hydrogen. So that's why the 1 gigawatt electrolyzer is a need. What we could do in the short run, of course, is that we could do as well. How did we get the offshore wind going? Well, we started subsidizing it. So one recommendation could be, why don't we subsidize use of hydrogen instead of using fossil alternatives? Simple way of doing it. I have another little idea for how we do it. And this may be the same. Why don't we then just start blending it? When we did this, it reminded me of one thing that I've forgotten. There is still in Denmark a requirement to build bioethanol into petrol. So in 15 years ago, we thought that today the cars would run on ethanol. So we had a requirement to blend ethanol into petrol. I think we should do the same with hydrogen in the natural gas. There's a number of studies on, can you in the natural gas grid, Stina's grid, can you blend hydrogen into this? Most studies says you can without problem blend something up to 20% into the grid. So one simple solution could be, why don't we just require that you blend 5 or 10% into the natural gas? That would automatically generate a demand. On supply, well, we need to start building this. I also understand why Ørsted is building a 10 megawatt electrolyzer. The largest ones today are 20 megawatt. So it's still more or less on the experimental stage. I think we need to do have some learnings, and then we can start building larger ones. In the meanwhile, what can we do? I think was Michael's point. We need a simpler way of doing this. Let's do carbon capture. Producing hydrogen is not new technology. We've known that for many years, that we do it from gas, steam, methane reforming. Let's just capture the carbon, and then we have a hydrogen source. I think this is a simple way. So that's one way of getting the demand going and get the supply going. The final piece in the puzzle is infrastructure. The good news on that is we actually have something on the infrastructure. We have the natural gas grid. And if you read in the different studies, some are for, some are against natural gas grids. I think natural gas grids is a very good idea. Most of the big studies that say, well, how can we transform the whole EU energy system to something that's renewable? They look at some different scenarios. And typically it's either we go electric, we go gas, or we go hydrogen. I'll show you the electric. This is going all electric. So this is a study where they try to see what will happen to the consumption of hydrogen and biogas if we go electric. And the thing is, well, we still need a lot of gas and hydrogen, And why is that the case? That's because you need to transport electricity. And Michael is right that it's a challenge to go from electricity to hydrogen and then back to electricity. But at least it's well-known technologies. It's doable. And if electricity is cheap, it may also be a cheap solution to this. I've been in the electricity sector for many years. I know how difficult it is to get high voltage lines down through Germany. We've been asking for that for 20 years. It doesn't happen. Maybe one way of doing this is reusing the gas infrastructure to transport electricity in reality. So we need the gas infrastructure long-term also. So that's a takeaway: maintain and develop the gas infrastructure. So then coming to this, can we then reuse the gas infrastructure? There's also a lot of studies in this. In reality, yes. This chart is our Dutch friends, Gasunie. They try to see, can we take some of our natural gas infrastructure and convert this to hydrogen? And the funny thing was that what they realized was that the old parts of the grid was better suited for conversion to hydrogen than the newer parts, because the quality of the pipes was bigger and in the old days. So it is possible to actually take part of the grid, build a parallel hydrogen grid alongside the natural gas grid as getting this going. Coming to my final point, so we need the gas grid long term, but my point is we also need the gas short term. Europe, we may think, I said, we think that the world is running on wind turbines. It's not. In reality, the electricity sector is running on coal. It needs to stop running on coal. And the simple way we know that most of the countries in Europe have plans to phase out coal. I think maybe the best way of getting rid of coal is let the market get rid of coal. And this chart here, the lowest one here, is a little bit similar to the one that Michael was showing. This is showing the cost of producing electricity from either coal or gas. And I know Rune is sad that the gas price has collapsed. I also have customers that are sad that the gas price has collapsed. But in reality, it's good for the green transition because it's driving coal-fired power plants out of the market. So we need to make sure that this process keeps happening. And what we can do as a society is make sure that the CO2 price remains high. So that we make sure that it's still better to do power from gas than from coal. So just summing up, it's not going to be easy. I think it's going to be pretty goddamn difficult to meet the Paris Agreement. I also think that power to X is part of the solution, and maybe even, in my opinion, maybe the only solution we can see right now. And then make sure we maintain and use the gas infrastructure to support the transition.
That was 15 minutes. Great. So that leaves us with 5 minutes for Q&A session. Any questions from our online participants? There is one. Our first question.
What fuel do you envision you should use for aviation?
Just repeat the question.
In the future?
Jet fuel.
And how will you produce that? Where will you get the carbon?
I think that's a very, very good question. And nobody today really knows the answer. I think that's...
My point is, I think you cannot do Ørsted's plan is to take it from biomass power plant. So the conclusion you make that we are not going to use biomass.
No, the question is, what do we use for aviation fuel? And where do we get this in reality? Where do we get the carbon that we need for the bio aviation fuel? I currently work on a project with somebody who wants to build a biomass-fired power plant. I think that's a Danish tradition that we build district heating plants with biomass. I'm not sure that in the long run is the right way of using the biomass. I think it's much easier to produce heat from electricity and then use the biomass to produce biogas that can be used to make things that are very, very difficult to electrify.
That's what I was just people say before we are not going to use biomass. It was just to point out.
So I think that biomass in the future will be biogas. I think that's a much more likely to happen.
That's a little longer run. But we can take our stuff.
Michaela, you have a question? No? Any more questions here from the audience? If there, hast du eine?
Someone is asking the question: Do you still think it's still worth investing in gas infrastructure, or is there enough available already to serve the way to the decarbonized future?
So I repeat the question: should we invest in gas in infrastructure, or is there enough of it? What's the answer?
And the answer is that there are parts of Europe where we need gas infrastructure. There are parts of Europe where the infrastructure today is mainly one way. So we need to make sure we have capacity so that gas can flow both ways. What is the right capacity in the system? I don't know. I think we will need more energy infrastructure in the future, not less, including also gas infrastructure.
One more. Where do you see the biggest chance for a fast coal to gas switch and fast CO2 reduction? East Europe?
The question is, where do we see the potential for coal to gas switching? Not so long time ago, we had the Polish Minister of Energy was in Copenhagen. And I was looking forward to hear him talk about how they switched from coal to gas. But in reality, they were not. Because with their power plants, they do not have the infrastructure. So they cannot switch their power plants to gas. They're building a nuclear power plant, which was a little bit of a shock to me. So I would like to say Eastern Europe, but in reality, that could be difficult. Germany still has a potential for switching from coal to gas.
I just remind that the reduction that comes out of Baltic Pipe is 3 times the reduction that we are looking at for the whole of Denmark.
I agree.
Just to remind,
I agree.
it is a huge reduction that you see.
But still in Poland, and Baltic Pipe is good for the Polish energy system, good for Polish CO2 emissions. But it's still difficult to switch the power plants from coal to gas. In Poland, of course, they have they have a lot of low quality energy sources that they can use gas for instead.
We're done. Thank you, Torben. Great presentation. I would like to mention that we, of course, make presentations available, and there are also 2 studies that Torben Frange Incentive has conducted, and we find them on your chairs, and we also make them available for download on our website or Incentives website. And Torben, you at one point you said so nicely, Stines grit. And I would like to introduce to you the woman that owns the Danish grid. It's Stine Grenaa Jensen, PhD, Head of Gas System Development at Energinet. And Stine, you're going to talk to us about a future with green gases in the Danish infrastructure. Thank you.
Oh, sorry. Let's see if it works. You can say if it doesn't. Thank you for the introduction. I can hear that we have been mentioned a lot of times in Energinet in the different presentations, and I'll try to take the different kinds of discussions into the framework of infrastructure, which is of course the core DNA for Energinet, and I will return to that, and then I'll put a bit more emphasis on the power to X discussion and perhaps make it a bit more not a buzzword, but what it actually is all about, and that it's also kind of a way of saying that you don't actually know what is going to happen, but one of the important parts to reach the ambitious goals is actually that we are able to remove barriers for a lot of different ways of reaching the different targets. And I think Power-to-X is a good example of that. At the moment, it's June, and even though we have had the COVID crisis, it's still, I don't know, you can see all the students getting their hats on, they are finishing the different exams. And June is also for me a month where I spend a lot of time reading different exams and being examiner of master degrees that are working on different subjects. And in several of the projects I took last week, a lot of them presented a theory called choice awareness. They wanted to state that it's important when we are all standing deep in what we know. We have a lot of assets in our current energy system. It's really difficult to be able to take leap jumps in order to find the new solutions and actually dare to take it. I was really glad to read that. But then in the examinations, I found out that they did a lot of interviews with the energy sector. And after the interviews, they were almost as if they forgot what they stated in the beginning, that they should be brave to suggest new things. But what actually happened, that all the actors they discussed with convinced them that the current assets, the current way of doing things were very good. And all the new things they had of good ideas was almost impossible. So instead of being really glad to see that we have a new bunch of students coming out of universities, I thought, does it really go that fast from thinking that you have good ideas, wanting to take leapfrog jumps when you go out and work in a company, to get convinced of doing otherwise? So I think one of my points today is also try to question a bit more what is actually happening and try not to convince new students coming out that they have to do like we do. So coming from a company of Energinet, you can see our infrastructure drawn in this picture. We own the transmission grid on both electricity and gas. I have a history in both electricity and gas, so I know well about both of the systems. We are doing investments with 40, 50, 60 years time span. We're trying to look ahead. We have also owned them for a lot of years. So I know from day-to-day basis that I'm at least one of those that have it very difficulty in finding the new solutions, but I'll try anyway. What we try to focus on the moment and what has been driving our business for the last, I would say, 10 years is actually integration of renewables. Integrating it into the grid, but not only just getting it to the grid, but also making sure that it actually creates value for the society, that it gets into the grid in the right way, low cost, high efficiency, and are used for the right purposes in the energy system. In the beginning, it was wind, onshore and offshore. Then, if you know the Danish history, we said solar, yeah, Southern Europe, good idea, never in Denmark. But as you know, it's not the same today. And on the question on what energy is actually coming online at the moment, our backlog on onshore wind and in particularly photovoltaics is huge. It's actually very large. Why you actually don't see it is that it's not in the support schemes anymore. They are applying to be put online without subsidies. And that's going quite fast and with a lot of money going into that technology. So don't underestimate what actually happens with PV, even in Denmark. Recently, we have actually worked a lot on biogas and integrating that into the gas grid. We are currently reaching about 14% in average. I think today we are more around 20-25%, but very nicely helped by summer, so the consumption is low. But in average over the year, we have reached 14% now, and we expect to go to 25% in a few years. So when I talk about this, about renewables, how to go in the future, what's the future energy, how do we take these leap jumps in order to reach the future, then I like to start actually with resources. What is actually available of resources and how do we utilize them in the right way? So if we start with resources that are good in a long-term perspective on electricity, this is a map of actually the current production of renewable electricity in the different areas of Denmark. And the colors just represent how large it is compared to consumption. And it's, of course, a way to say that infrastructure is very important because you need to transport the energy from where the resources are to where it's actually consumed. That's one point. But the other part is, as I said, the pipeline for new projects coming online is not only offshore wind turbines, it's also projects on land, both onshore and PV. So we have a huge potential for utilizing these resources and also making all the areas you see on the map being plus on renewable electricity compared to electricity consumption. So in a Danish context, it's relevant to discuss what's actually to be done with this additional electricity and what kind of value can it actually create. On the gas side, you can start with biogas that comes from a limited resource. And we also have a huge extension, and I didn't put all the new biogas facilities on this map because at the moment the news are coming online every month. But there it goes very fast as well, and they are also located in areas. It's mainly in the western part of Denmark, and we are currently investing a lot in transporting biogas from these part of the grid, from decentral production of gas, and then the other way. And from those of you who know the natural gas grid, we are only used to taking it from the North Sea or from Germany and then push it to the consumer. And now we have to handle it the opposite way. And that actually causes a lot of investments at the moment. But in my opinion, green gas is not only biogas and it's not only methane. Gaseous forms of energy is actually a lot of different forms. And we have a lot of knowledge, of course, from handling methane, but we also have to think about how to utilize that on other gases. And it could, of course, be hydrogen, as we spoke about. But when we talk about CCS, for example, we also have to discuss transport of CO2, which could be transported as a gas in the same way. So that's some of the areas we're looking into. When we're discussing this about the resources we have available and how we use them well, we of course also take, as was said before, the discussion on how to support energy for the sectors that are not directly easy to use electricity for. And that actually constitutes, as Torben mentioned, a large part of the total energy consumption in the world. And it's a good idea to look in how to solve it. This figure is illustrating how large a part that can actually be electrified. That's a small mark in the circle. So it's actually not the large potential. So there's still a lot to handle in another way. Then approximately more than 1 year ago, we handed out a report that's saying that we think that using hydrogen as feedstock for other fuels could be relevant before 2030. I had a phone call from a journalist saying, what are you geeks doing now? Do you think this is a good idea? What are you using the consumer's money for to do a report like this? But actually you all said in the previous presentations that the cost we see at the moment on renewables going very fastly down, and I don't think we are at the level we will see yet. But also I think a lot of people thought that biogas would be high for a very long time. That's dropping as well. I mentioned electrolyzers, prices on hydrogen. The report done by IEA just last year, stating a price in 2030. We saw now the first contracts actually stating prices in that level. We can discuss whether or not it's how valid these single contracts are, but we actually do see prices going down in this area as well very fast. And then one thing I like to do is look around the markets, follow the money, who is investing in what. And this hydrogen area is getting a lot of funding, not only in Europe, not only by green companies. Now some of the oil companies are going into the same, gas companies. But you also see this kind of the same activity in China, for example, and they are putting a lot of money in this as well. So I think we have to look at it. We have done a bit on investigations on the Danish case, what's actually the potential for using hydrogen for other areas. And it can be used, of course, directly where you have hydrogen today, but that's not in energy, that's in chemicals or other processes, like, for example, refining on refineries. And there it's more directly to start on that, but it could also be the production of ammonia for agriculture. They need it for fertilizing the fields, so that's also a way to use electricity or renewable electricity for a commodity that has previously been produced from natural gas, for example. If we look into some of these different potentials, we actually look into, if we take the first step, it's a doubling of the current electricity demand in Denmark. And if we look into the more high potentials, we actually talk quadruples of electricity consumption, and that's huge amount of electricity. And of course, it is available. And then comes the question that some of you had before, so where do the CO2 come from? And at the moment, we actually do see a lot of the resources coming from biomass. That's important for these different types of commodities that can be produced. But we actually do see the potential for that in Denmark. In the beginning, we can also use it for fossil fuels, but that's not a valid way to go in the long term. Jumping into the infrastructure part. When you get this new way of talking about power to X and hydrogen and a lot of other things, it's gets a bit more difficult when you go into the detail and how do you actually construct the different facilities, what's actually needed. But when you talk about that, you actually saw on Torben's slides that you have a lot of different feedstocks for producing the different types of fuels. And perhaps you have electricity, you have hydrogen, you can have CO2 depending on what product you actually want to produce, but they are not all located in the same place. And no matter how we do it and where we place it, we need to transport something. It can be electricity, but I know from our experience, it's not easy to build overhead lines. And we kind of looked a bit scared about this project in Copenhagen because I saw overhead lines coming in from wherever and going through Copenhagen and having, I don't know, 2 lines of 400 kV or whatever. And I know what difficulties we had in Jutland building 1 line. So that could be a huge difficulty for the project. It's not easy to build gas infrastructure either. We right now are in the process of constructing Baltic Pipe, and it's not easy either. But we have to take the discussions. And in Energinet, we have 2 focus areas on this. We have the electricity part because that's part of our company, and we have gas. And I really don't care if it's methane, CO2, hydrogen, whatever. We just have to make sure that the right infrastructure is there for the right product or for what's actually needed to create value from the renewables. And that's where we try to look into our way of working. And then an interesting part of it is, of course, we can discuss it in Denmark and what's important and how do we actually reach the different targets. But markets and stability, volatility is very important. We heard that from Ørsted as well. And there, the linkage between international markets is actually a very important part of the development. So we actually spend a lot of time working with our colleagues, and here you can see it's connected to Germany. And I know that in the new German strategy for hydrogen, they have a map that actually has a link that matches this one. And that's of course because we think that we already now have to discuss or take into consideration whether or not we should do international markets on hydrogen as well. And it is, of course, a trade-off between cost of different types of infrastructures, the value they create. But I do think that we have to take that discussion into mind. Then this was mentioned, hydrogen from Morocco is actually what's said here. Hydrogen from renewables is, yeah, you can produce that, and it's a technology that's proven technologically. We are lacking upscaling, but it's not just creating value in itself. It has to compete with other types of hydrogen. And it could be what's called blue hydrogen from Russia. They are looking into technologies to take CO2 out of natural gas and then export hydrogen to Europe. It could also be renewable produced hydrogen from Morocco that comes up from the south through Italy and Spain. And there are projects actually on that. And I know the German project is also talking about importing hydrogen from Northern Africa. And there, from our point of view, there is cost components that are important. I think that the pure hydrogen price is cheaper in Africa compared to hydrogen from, for example, offshore wind in the North Sea. But then we have to transport it. And we also have to look on the production patterns when we look into a facility like this. If you produce only on solar power, you have a number of hours of production, and that's another figure when you talk about offshore wind. But if you are in an energy system that has a global market and can use other types of electricity at the same time, then it can actually drive down costs in the Northern European region as well. And that's a part of our discussions as well. So just to finish off, I don't see one road ahead on this. I don't come here today and say I see the gas infrastructure look this and this way. I have some part of the business working on methane. I think that's important, at least also for Danish industry. It's also important for our Polish colleagues, where we make a contract for at least 2038. But we work on blending. We work on hydrogen infrastructure. We also work on CO2 infrastructure, because I don't want to be the one to blame if we are too late or we don't facilitate the right type of infrastructure or know the right things about the technical features of the different ways to go. So I hope that we can take some jumps in that direction. I'm confident we can do it together.
Thank you, Stine, for presenting your grid.
You also managed to stay under those 20 minutes, and I think we can take one more question for you, here from participants here or from online
I have
participants.
A quite long question. Do you believe that Denmark will be in the position to become self-sufficient in energy supply, or will a strong interconnection to neighboring countries still be necessary for security of supply? If interconnections would be needed, what countries will be important?
So the question was about self-sufficiency and about the interconnection.
Security of supply and infrastructure. What I just presented on different ways, one of the very important part of actually being able to be competitive with these green solutions is flexibility. Flexibility, and not only on day-to-day, but also on long-term, for example, on storage facilities. And the easiest way to handle that and the cheapest way is to use collaboration with your neighbors. So I don't think we'll see less. I think we'll see more. I talked about doubling and quadrupling the electricity production, but I actually think that we should keep the infrastructure low on that. Let's say if it's 4 times on consumption, let's hope that infrastructure is 2 times, something like that. But it will be something that continues to be important also to keep down volatility and the interest in investing in Denmark. So I think that the numbers, adding them together in average, we can be self-sufficient, but only if we keep the borders open on all energy forms. And which countries are most important? We are actually almost connected wherever we can be. And what we're doing at the moment, going to Eastern Europe on the gas system, is actually a very good way of getting Europe connected better in a way also. And we know that some of the projects also look into a connection to Poland on electricity. So that's a way to go. But we are dependent on our neighbors, and I think we'll be ahead as well.
Great. Do we have another question there? No. Well, we were supposed to finish at 18:25, and it is 18:25. That's Danish punctuality for you. Thank you very much to our four speakers. Great presentations, and I think you provided lots of aspects on that question: is sustainability sustainable? My takeaway is yes, it is. It's got to be. Economies of scale, I think, plays a very vital role in answering these questions. And the farther we get on that journey, the more economies of scale we have. So thank you for taking us on this trip, 80 minutes around the energy world. Thank you again to our sponsors, Wintershall Dea. And for our presenters, we actually do have some presents there. Sustainable presents for you. German wine. And yeah, please come up, step forward. Michael. Thank you. Thank you. Rune. Thank you very much. You're welcome.
Thanks.
Wine is also a good, what is it in English? Stichwort in German for talking about our wine sponsor. That's Jörn Krüff, our old friend, Esprit du Vin. That's Jörn over there. And you're going to be able to meet Jörn because he is going to show you a few of his finest German Rieslings that's going to be outside. Both places. As we finish this conference, I would like to, I ask you to go out, enjoy the sun that has returned. There are benches and tables outside on that terrace. You can also stick around here inside, and there will be a tapas menu served for you on different places here. Thank you for being here with us. Thank you to our online participants for being with us for the General Assembly and for this conference, and to all of you that are present here in Portland Towers. Please enjoy the evening with us here at our summer party. Thank you.